Hi guys, welcome to the 5th video of integration on the channel Mathphile. If you've not watched the previous videos, I would advise you go back to watch the techniques of integration. We're going to use some of them, some ideas to integrate the functions in today's video. So in today's video, we're going to look at integration of trig functions, simple trig functions. Some may be complicated, some may be simple. Then we move on from there. So we recall that for you to integrate, you don't really need to know much about it if you are very good with differentiation. Basically, the same example again. So 3x squared dx. This is asking you which function would you differentiate to get 3x squared. So if you know this one, we are good to go. We don't really need to even know that we need to add 1 to the exponent, or we need to add 1 to the exponent and divide by the new exponent, because we know that if you differentiate 3x squared, differentiate x cubed, you get 3x squared. So that is the idea we're going to use in today's video. The first thing I'm going to ask you is y is equal to integral of sec squared x dx. Now, there are several ways to integrate this one by showing steps, but we're going to go straight for it to see if we can get this one. This is asking you which function are you to differentiate to get sec squared x. So if you know your differentiation rules very well, you know that if you differentiate tan x, so d dx of tan x, this will give you sec squared x. So the answer to this question is going to be tan x plus c. Again, like I said, there are techniques we can use to actually show work into this, and we're not really going to require this one in additional mathematics for now. So the main idea is for you to know the function to differentiate to get whatever is enclosed in the integration. Another example will be y is equal to integral of, let's say, sec x tan x dx. Now, which function are you to differentiate to get sec x tan x? If you know this one straight away, then that becomes our answer. If you don't, then we'll have to find a way to solve this one. But this should be part of the rules you know at your fingertips. If you differentiate sec x, you end up getting sec x tan x. So you know that the answer to this question is going to be sec x plus c. So basically, this is using the concept of the opposite of differentiation, where integration will reverse everything that differentiation has done. So if you know the function to differentiate to get whatever is enclosed inside the integration, we'll be good to go. The main thing we're going to focus on is going to be the differentiation of sine and cos. But let's see if I can recap all the differentiation rules for the other ones. So d dx of sine x will be cos x. d dx of cos x will be negative sine x. d dx of tan x will be sec squared x. Then if you differentiate cosec x, you get cosec x negative cot x. Then if you differentiate sec x, you get sec x tan x. And if you differentiate cot x, you get this one to be negative cosec squared x. So this is just a recap from differentiation. So if you integrate cos x, you get sine x. If you integrate negative sine x, you get cos x, and it goes on that way. So once you know the function to differentiate to get whatever is enclosed in the integration, we are good to go. So an example, if I give you integral of cos x dx, I'm basically asking you which function would you differentiate to get cos x. So from the previous one, we know that if you differentiate sine x, you get cos x. So the answer to this question is going to be sine x plus c. So which function are you to differentiate to get cos x? That becomes the answer. So anytime you come across integral of cos x, we are expecting an answer to be sine x. Similarly, if you come across integral of sine x, dx. What do you think the answer is going to be for this one? Unfortunately, if you go up over here, there is nothing to differentiate to get sine x. The closest to this one is negative sine x, that is if you differentiate cos x. So let's be smart about this one, because we know that if you differentiate cos x, you're going to get negative sine x. How about we differentiate, if I give you y is equal to negative cos x to differentiate. If you differentiate this one, we can say that dy dx is going to be equal to the negative, and if you differentiate cos x, you get negative sine x, which it multiplies through, and you get the answer to be sine x. So I now know that if you differentiate negative cos x, you get positive sine x. So we can say that the answer to this question is negative cos x. And this is what we're going to use a lot. So please be mindful of this one. Be very mindful of this. So if you integrate cos x, you get sine x. And if you integrate sine x, you get negative cos x. You're going to use this a lot. Okay, so let's dive into the use of this one. Okay, I think the video is getting longer. Yeah, let me just finish up. We are under 10 minutes. So okay, so let's say we come across integral of y is equal to integral of cos 3x plus 2 dx. Now, to integrate cos x, let's try to refer back. If you integrate cos x, you get sine x. So please take notes. If you integrate cos, you get positive sine. If you integrate sine, you get negative cos. So if you integrate cos x, this is going to give us sine x. So sine 3x plus 2. Now we multiply this one by 1 over the differential of what is inside the cos, just like we've done for all the functions we've talked about before. We've talked about the exponential function, the log function, and now we're talking about the trig function. So we multiply by the 1 over differential of the argument. Then we finish off this with a plus c. So this gives you 1 over 3 sine 3x plus 2 plus c. So let's try another question. Let's say y is equal to integral of 4 cos 5x minus 9 dx. So pause the video and try to do this by yourself. Okay, welcome back. Now let's go back again. It's fine to write the rules down somewhere so that you can go back to it, since this you are just being introduced to it, so that you get so familiar with it. So we know that when you integrate cos, you get sine, and there's a cos question. So if I integrate cos, so let's the 4 come. If I integrate cos, I get sine. So I get sine 5x minus 9. Now I multiply this one by 1 over the differential of what is inside, which is 1 over 5. Then we simplify this one nicely. This gives you 4 over 5 sine 5x minus 9 plus c. And that will answer the question. So let's try one more example, then we end today's lesson. So we've got y is equal to integral of sine 7 minus 2x dx. So the answer to this one is going to be, now we can go back to refer to the formula sheets. What would you get when you integrate sine? When you integrate sine, you get negative cos x plus c. So we go back, because we are integrating sine, we know the answer is going to be negative. So we go negative cos 7 minus 2x. Now when you are done with this one, you multiply by 1 over the differential of what is inside, or basically the argument. The differential of this is going to be negative 2, then plus c. This negative can cancel out this negative. So simplifying this to 1 over 2 cos 7 minus 2x plus c. And that answers the question. So generally, we say that if you've got integration of the form y is equal to cos ax plus b dx, we say that the answer to the question is going to be if you integrate cos, you get sine. So you've got sine ax plus b multiplied by 1 over the differential of what is inside, a plus c. Or you can basically take off this one and just put the 1 over a over here. So that will be better. Then let's differentiate this one. Okay, good. And similarly, if we go y is equal to integral of sine ax plus b dx, this becomes 1 over a cos. But if you integrate sine, don't forget that it's a negative. So negative cos ax plus b plus c. And that will end today's lesson. In the next set of videos, we're going to look at how to solve. We combine the laws, and should I say laws, the techniques of integrating into one question, and we start solving some past question. Yeah, so please share this if you know anyone that would need it, and subscribe if you've not done that already. Bye bye for now.